Hello, Proviso students, and welcome to Notes on Areas of Basic Shapes. Before we get into calculating the areas of basic shapes, let's actually define what we're talking about when we ask what is the area of a figure. And what we're really talking about is how much space in the figure. A more precise definition is the area of figure is the number of square units needed to cover the figure completely. So how does area differ from perimeter? Because a lot of times students get those two confused. They're not sure which one's which. The area is the amount of square units or space inside a figure. So how much of that square units are in that shaded region, where the perimeter is the distance around. So perimeter is the distance around the figure. And that's basically the two differences. We're going to be dealing mainly with the area. You might be asked questions as you work through your different evidences regarding perimeter, but the main crux is going to be, or the content focus is on the area. There are certain formulas that could be utilized to calculate the area of a figure. These three formulas come straight out of the SAT test document. So when you take the SAT test your junior year, you will have this in the directions on the math portion of the test. So one of the basic shapes we're going to deal with is a circle. And the area of a circle is equal to pi, approximately 3.14, times the radius squared. A rectangle is another one, and the area of a rectangle is length times width, or base times height. And then the third basic shape is triangle, and that is 1/2 times base times the height. So those are three figures you're going to be working with. More specifically, rectangle is a special form of an object called a parallelogram, and we're going to talk about that next. Shape number one we're going to discuss is a parallelogram. So what is the definition of a parallelogram? Parallelogram is a four-sided figure in which the opposite sides are parallel to each other. Meaning that if you extend out those sides, they'll never touch. Examples of parallelogram. Well, one specific example is a rectangle where we have four right angles and the opposite sides are parallel to each other, and they also are equal to each other. But parallel, to denote parallel sides in geometry, we draw little arrows. So the left side and right side is parallelogram, which is a specific parallelogram called a rectangle because all four angles are right angles. Those two sides are parallel because I have single tick marks there, or single arrow marks. And because I have double arrow marks on this top and bottom, that means the top and bottom sides are parallel. So rectangle is a special parallelogram. Another special parallelogram is a square. All four sides are equal and you have right angles. And once again, top and bottom are parallel. Left and right are parallel. A generic parallelogram will look like something like this, where the top and bottom sides are parallel and the left and right sides are parallel to each other. Characteristics or facts, we're going to just focus on the area model or the area calculation. So area is equal to length times width, or another way to write that is area is equal to base times height. And I'm going to go back to our generic parallelogram in our examples. This black figure, to find the base, that is this side right here. To find the height, it's going to be an altitude. So it's going to be the distance from the bottom side to the top side in which it intersects either the bottom side or top side at a 90-degree angle. So this here is the height. All right. And non-examples. Oh, a trapezoid is a non-example of a parallelogram. It's a four-sided figure, but not all opposite sides are parallel. With the trapezoid, and this trapezoid I drew, the top and bottom sides are parallel, but not the right or left, so it's not a parallelogram. And then something like a kite, I can have something like this. Once again, opposite sides are not parallel, so it's not a parallelogram. So if you have a anytime parallelogram, the area is base times height. So let's do some examples of problems you'll see just to reinforce how to calculate the area. This is a prerequisite skill to help us build up so that when we get to surface area, we have a better idea of what we're doing. Alrighty, so first example here, I'm going to call it A. I have a parallelogram. Top side, bottom side are parallel. Left side and right side are also parallel to each other. So area is equal to base times height. Oops. And you figure out what the height is and the base. Base is going to be 1, 2, 3, 4 units. And the height, here's the height right there. That is 2. So 4 times 2 is 8 square units. Let's look at B. I have a rectangle here. It looks like a rectangle. I'm assuming these are right degrees and right angles, 9 degrees. So once again, area is equal to base times height. So I got 2 yards times 5 yards. That'll give me 10 yards square. And then the last figure is our last example. See, square with sides 15 inches. Well, we know a square has all sides are the same length. So area will be 15 inches times 15 inches. That gives us 225 square inches, or inches squared. Shape 2 is a triangle. I'm sure we're all pretty familiar with triangles. The area of a triangle is found by calculating 1/2 times base times height, which could also be rewritten as base times height, whatever that product is, divided by 2. So either way you want to do it, I'm going to stick with this particular formula because that's what's given to you on the SAT test. So example A here, I want to know, I got to figure out what area is going to be 1/2 base times height. So let's figure out what the base is equal to, what the height is equal to. Base is going to be 1, 2, 3, 4, 5, 6, 7 units across. Height's going to be 1, 2, 3, 4 units up. So area is equal to 1/2 4 times 7, or 7 times 4 does not make a difference. 1/2 of 4 is 2. 2 times 7 is 14. So 14 square units. Let's look at the second example. I'm going to call B. Once again, what's the base and what's the height? Base is going to be 1, 2, 3, 4 units across. Height is going to be the length of that segment right there. So I'm going to start off here and go up 1, 2, 3, 4, 5, 6, 7. So area is going to be 1/2 4 times 7, which also gives me 14 square units. So in examples A and B, we have two different shaped triangles, but they both contain the same amount of space within their boundaries of 14 square units. And finally, this last one here on the right, my base, go across one. There's 1, 2, 3, 4, 5, 6, 7 units across. 1 unit up. Area is equal to 1/2 base times height. 1/2 of 7 is 3.5. 3.5 times 1 is 3.5. So I got 3.5 square units, or units squared. So our answers can be decimal values. Don't freak out if you get those. That's perfectly fine. But that's how you find the area of a triangle. Our last shape is going to be a circle. We all pretty much know what a circle looks like. You got some point there, and you got a circular fashion going around. Oops. And that dot is the center. And distance from the center of the circle to any other point on the circle is going to be called the radius. So let's actually put down the formal definition of a circle. Circle all sets of points that are equidistant from a fixed point called the centered circle. And that equidistant distance from the center to any point on your circle is called the radius. So with characteristics or facts, let's define that. Radius is the distance from the center to any point on the circle. Another characteristic or fact is that the diameter or the radius, change colors, radius equals 1/2 the length of the diameter. The diameter is the distance through the center from one point of the circle to another point. So that's the diameter right there. And one more fact, and it's given to you in our formula, is that area is equal to pi times the radius length squared. All right. In a non-example, something that's not an example, something might be like oval shape. Oops, that's horrible. Like an egg. That's a little better. So let me draw that. Let me get rid of this. Okay, so let's look at these three examples. Find the area of a circle. Oops, don't want that. Area of a circle is pi times the radius squared. So what we got to do is find the radius of these circles. So here's my center. And if I go straight across to my circle, the distance from the center to the circle is 3 units. So in this problem, radius is equal to 3 units. So area is going to be pi times 3 squared. That gives me 9 times pi units squared. So feet squared, inches squared, centimeters squared, miles squared, whatever. You could also take 9 times 3.14 to get your approximate value. And I need to grab a calculator to do that. 9 times 3.14, 28.26 units squared, or squared units. And that's the answer for that one. Let's look at this middle example. My center is right there. I'm going to go across. So in this problem, the radius is 1.5 units. So the area is going to be pi times 1.5 squared. And that'll give me 2.25 times pi units squared. And once again, if I go 2.25 times 3.14, I get, 7.07 units squared. And that's how much space, how many square units there are within the circle. And then the third one, it's verbal. A circle with a diameter of 34 centimeters. We don't no figures drawn here, but if I wanted to, I could draw a little figure. Here's my center. Now, the whole distance across, let me change colors. This whole distance right here is 34. So that means that this distance right here is going to be half of that, or 17. So the radius is 17. So my area is going to be pi times 17 squared. That'll give me 289 pi units squared. And if I take 289 times 3.14, I get approximately 907.46 square units. And that's how you find the area of a circle. So just gotta find a radius. Once you got that, it's just putting in your calculator to do a little number crunching. All right, final sets of questions. Sometimes you are given an area and you need to find one of the missing dimensions, such as, I'm going to call example number 1 right here. The area of a parallelogram is 450 square miles. The base of the parallelogram is 30 miles. What is the length of the height of the parallelogram? So the base is 30, so it's a parallelogram. So we are using area is equal to base times height. We know that the whole area is 450 square miles squared. That's going to equal 30 miles times the unknown height. So what I got to do, divide both sides by 30 miles. And when I do that, these cancel, and height comes out to be 15 miles. Because this mile unit will cancel out with will cancel out the square, and let's left with miles. There's my answer. Problem number 2. The area of a triangle. Triangle's 1/2 times base times height is 450. So 450 square meters. We'll go in for the area. I got 1/2 times a base of, don't know, but I know the height is 30 meters. So I got 450 meters squared. Now 1/2 times 30 meters is 15 meters. Times B, divide both sides by 15 meters. These cancel, and the base would be 30 meters. Because 450 divided by 15 is 30, and meters squared divided by meters is meters. All right, let's look at number 3. The circle has an area of 50, so area is equal to pi r squared. So 50 square centimeters is equal to pi times r squared. So I'm going to divide both sides by pi. And I'm going to start getting some decimal numbers because I'm going to take 50 divided by 3.14. And when I do that, I get 15.92. If I round it to the nearest hundredth, that is equal to r squared. To undo the square, we got to take the square root. And when I do that, I get the radius. And square root of 15.92 is 3.99. And the units are centimeters. So that's how I find a missing radius if I know the area of a circle. Number 4, the area of a circle is 36 pi square inches. What's the length of its circle's diameter? Diameter now, not radius. So, area of a circle is pi times, A is equal to pi times r squared. We know area is 36 pi. That's equal to pi times r squared. Divide both sides by pi. Pi's cancel there. Pi's cancel there. 36 is equal to r squared. Take the square both sides. You get 6. So the radius is 6. So in my circle, this is 6, which means that this diameter here would be 6 plus 6 or 12. So diameter is equal to 12, and the units is inches. So 1 foot, 12 inches. Number 5 was the length, this one. So we got 21 units squared equals 7 units times, come on, L. Divide both sides by 7 units. These will cancel with these, and L will equal 3 units. Because 21 divided by 7 is 3, and units squared divided by units is just units. And then we have this last one, area of a triangle is 1/2 base times height. They tell us the area of this triangle is 10 centimeters squared, equal 1/2 times the base. Base is 5 centimeters. Height, we don't know. So that'll be 10 centimeters squared. 1/2 of 5 is 2.5 centimeters times height. Divide both sides by 2.5 centimeters. These cancel. Height is equal to 4 centimeters. Here's your answer. All right, we're done with these notes. What you're going to do now is do a little practice on this, and hopefully things go well. If not, ask your teacher or a competent classmate for assistance. All right, bye-bye.